So this lecture is for molarity. Molarity is the concentration of a solution, and it's expressed in the number of moles of solute per liter of solution or volume, in liters. So the formula will be molarity equals moles over volume over liters. You may see something like this, but it means the same thing. Remember that you can rearrange the equation if you need to. So for example, if molarity is moles over liters, you can solve for moles by multiplying both sides by liters. And in doing so, liters cancel out. You're left with liters times molarity equals moles. And from there, you could technically convert to grams by multiplying by the molar mass of a substance. If you want to, if I ask you for what is the volume, you may do the same thing. You may multiply both sides by liters and then divide both sides by molarity. So liters equals moles over molarity. So like I said, technically the unit is moles per liter, but it can be symbolized by a capital M. So what is the molarity of a solution that contains 50 grams of sodium hydroxide in 850 milliliters of solution? So remember, when we're solving for molarity, we have a few things we need to keep in mind. Molarity is moles per liter. If you look, we can use this to to convert grams to moles. And then here we have 850 milliliters, and we want liters, so we can use our King Henry. So 1, 2, 3 to the left, this is 0.85 liters. We're also going to convert sodium hydroxide grams to moles. So 50 grams. So in 1 mole of sodium hydroxide, 22.99 plus 16 plus 1.008 equals 39.998. So 50 divided by that number is approximately 1.25, a bunch of zeros. So now I can just technically divide. In my calculator, I'm going to use this number, 1.25, all that, divided by 0.85. I end up with the following: 1.4706, etc. So follow sig fig rules. I have two sig figs, so it becomes 1.5 molar NaOH. What is the volume of 1.50 molar copper 2 sulfate that contains 35.0 grams of copper 2 sulfate? So we have M here, so that means we have a molarity. We have a volume, but we have grams. So we're going to convert this grams to moles first, because we're going to have molarity equals moles over my volume in liters. So I'm going to multiply both sides by my volume. Then I will eventually divide by my molarity. Eventually I will. Oops. So 35.0 grams over 1 times 1 mole over, let's see, so 63.55 plus 32.006 plus 16 times 4. So 159.61 grams So I end up with 0.219 something moles. So I'm going to take this long number and plug it in here in the bottom. Well, not the bottom, but where the moles are. And I'll divide that by my molarity, 1.50. I'm going to end up with, so I'll put this here at the bottom, 0.14618. So 0.146 liters. CUSO. How many grams of NaCl are in 2.53 liters of 0.750 molar NaCl? So I have liters, molarity, so I'm identifying my knowns and unknowns. I have my volume. I have my molarity right here. So my formula should be still the same. Molarity equals moles per liter. I'm going to multiply both sides by my liters. That'll give me liters times molarity equals moles. And then I will convert this over to grams because I want to get the grams of that. So 2.53 times 0.750, that will be my moles for this. So 1.8975 moles. To convert that over to grams, I'm going to multiply by the molar mass of NaCl on top, which is 58.44. So 1.8975 times 58.44 is, so you can clearly see it, 110.8899, 3 sig fig, so it's 111 or 111 grams of NaCl. So we're also going to look at dilution of molar solution. So whenever I purchase like hydrochloric acid from the lab, they give it to me in a 12 molar. I ordered it in a 12 molar concentration, meaning it's really, really concentrated. And usually that's the best way to buy it, so you can just dilute to what you want to get, or like for y'all to work with in class. Like 12 molar is pretty concentrated versus 1 molar or something like that. So adding solvents, meaning like water usually, increases the volume of the solution without changing the number of moles, but that the effect is that it's going to change the concentration of the solution. It's going to decrease it. So it's going to be less concentrated. So the formula to use is M1V1 equals M2V2. So your concentrated molarity and volume, and then your diluted molarity and volume is the second sense. Your volumes can either be in liters or milliliters, but they need to be the same and consistent. Hydrochloric acid is obtained at a concentration of 12.1 molar. How many milliliters of 2.1 molar HCl, or hydrochloric acid, must be used to prepare 2,000 milliliters of 0.500 molar HCl? So I want to go from 12 molar to 0.5 molar. I really want to dilute it. So usually if you have a formula, M1B1, you should also label your knowns and unknowns. So M1 will be 12.1 molar. How many milliliters of it? That means that I'm trying to solve for that. That's my V1. So if you see it to where it's saying milliliters of, like this, like that, those are usually, that means they're paired together. So V2 is going to be 2,000 milliliters. M2 will be 0.500, 2.500 molar. Actually, to make it a little more digestible, let's see. Let's make this, so it will be 2.00 liters. Oh, that's a lot actually. Try to keep it to 3 sig figs. That's what I meant. So I'm going to solve for V1. V1 equals M2 V2 divided by M1. And I'll plug in my numbers. 0.500 times 2.00 divided by 12.1. So 0.0826 liters. But if I want to convert it to milliliters, I can just go 1, 2, 3, so 82.6 milliliters. It just depends on what's being asked in the question, to be honest. But I decided to change this to 2.00 liters right now to make it easier for sig figs. If I add 35 milliliters of water to 125 milliliters of a 0.15 m or molar NaOH solution, will be the molarity of that diluted solution. So if I add 35 to 125 of a 0.15 molar solution, so my M1 is 0.15 molar, my V1 is 125 milliliters. I'm adding 35 to that, so my V2 is 125 plus 35. That's going to be 160 milliliters. What is my new molarity? So M1 V1 equals M2 V2. 0.15 times 125 divided by my M2, or my V2, I'm sorry, which is 160. That will be my M2. So 0.15 times 125 is 18.75 divided by 160. So my second molarity would be 0.12 molar NaOH. NaOH is easy to use, but it can be different acids or different bases, etc. If I add 100 ml, if I add water to 100 mLs of a 0.20 molar solution until the final volume is 160, what is the molarity of the diluted solution? So I know I'm trying to solve for M2. I have an M1 because that's the only other capital M, but I kind of stopped talking about, I skipped the volume because this one is worded a little bit differently. So if I add water to 100 milliliters of a 0.20 molar, so we can kind of tell that that B1 is 100 milliliters until the final volume is 160. So the final volume is 160. So what is the polarity of that diluted solution? So M1 V1 equals M2 V2. Trying to solve for M2. So M1 V1 over V2 equals M2. So 0.20 times 100 divided by 160 is my M2. So 20 divided by 160 is 0.125. Put this up here. So 2 sig figs, 1 sig fig. So technically this should be 0.1 molar NaOH. Alrighty, so that's it for now for this lecture. Let me know of any message. Thanks, bye.